Today we're going to be doing some Leetcode, uh, and this is different from what we're doing so far, which is Codecrafters, where we've implemented systems projects. And the reason I wanted to do Leetcode is just because the Primogen calls it the secret handshake. So apparently it's unfeasible or infeasible for companies to hire based on actual programming competency. In my understanding, it just takes a lot of time. So, if you, for example, ask a candidate to implement the shell Codecrafters project while sharing their screen, and during the interview process, it just takes too long, I think. And so, therefore, they need a first line of defense, and Leetcode seems to be the first line of defense. And yeah, I think I just find it very annoying, Leetcode, because yeah, I know a lot of great programmers who simply don't, who simply uh, are not good at Leetcode. But I assume the apologies. I assume the point is that if you can get good at Leetcode, it means that you're good either at algorithms or memorizing solutions. And if it's the former, then you're going to be able to get good at programming too, or you are good at programming too. So yeah, I really don't want to do Leetcode, but here I am, kind of forced to do it. As a Yeah, so I have a lot of questions actually about Leetcode, and the first is, who are the people that are making these problems, and do they have pedagogy in mind? And again, so what is programming, and what's the nature of logic? So, for example, yesterday when we implemented the shell project, yeah, I had a few ideas on how to process text, and I converted them into code. But there, I didn't need to know about binary search and graph algorithms and so on. And I'm not saying that one shouldn't know of these things, but rather testing people on their ability to code these up, it just seems like kind of arbitrary. And I would just rather work on something that I'm actually interested in, like building a shell or one of the other Codecrafters projects. But yeah, I just wanted to try something new, so I guess here we are. Let's just do some Leetcode. I'm gonna just have to shove my worries and concerns about the makers of these Leetcode problems and whether they had pedagogy in their mind. But sure, I can see arrays and hashing. Again, so this is just for context. This is Leetcode. So Leetcode has a lot of problems in a lot of different topics. So Leetcode provides a structure to approach different topics, just so that you're not solving problems from the same topic over and over again, and even when you've understood the topic. So, for example, if you're good at arrays and hashing, so you're good at using lists and you're good at using dictionaries, and I think that this contains problems that use sets as well. You don't need to continually solve an increasing number of problems. And you can move on to, say, graphs, which is another area that people seem to test. So, and linked lists and trees and tries and priority queues. So I think this is an effort to uh, group problems that are representative of the topic that we're trying to learn. And yeah, so in this series, we're just going to work our way through the entire graph here. Is this a graph or is this a tree? This is a graph because because there are two edges that reach into this node. So there's a cycle here, so it's a graph. Anyway, yeah, I think we can get started with arrays and hashing. Let's get started with contains duplicate. And I'm going to start a stopwatch just so that I have a better idea of after what time in a work session my concentration starts to drop and after which I need to break. So let's start the stopwatch and we can get started with the problem. Given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. The element 1 occurs at the indices 0 and 3, and so therefore it's true. Here all elements are distinct. And there are 10 to the 5 elements in the array at max, and every element in the array is between minus 10 to the 9 and 10 to the 9, which I think is an int 32. So how would I approach this problem in real life? So if I had a list of things, so a list is an ordered sequence of, an ordered finite sequence of things. What I would do is I would maintain a table of the things I've seen, and I would maintain a table of things I've seen, and as I'm iterating through the list, if I see an element that already exists in the table, it means that it means that the list contains the list contains a duplicate. So that's how I think I'm going to solve it. So yeah, so in the real world, what I would do is maintain a table of things I've seen, and the way I'm going to match entries to the table is by eyeballing it. I'm going to look through the table and see if it already exists. That seems to be very similar to just looking through the original array again. So I think that's something I can do. So for a given element, I can look at all the previous elements, and if any of the previous elements are equal to the current element, then it means that there is repetition in the array, and there is a duplicate. Yeah, I think here's where we get into complexity concerns, where, again, so off the top of my head, I know that it's an O of n squared approach, O of n squared solution, and it's not going to work for this particular problem, since the length of the nums array is up to 10 to the 5. I think anything that exceeds 10 to the 9 in total doesn't work. It times out. But how do I want to proceed? While I actually know this off the top of my head, I don't actually understand it. I don't think that I understand it, because I don't understand all the cases where uh, all the cases where it's n squared, in the sense that very often it's a lot less than n squared, right? And that's okay. Let's forget about complexity for a bit, and let's just do it how one would do it in real life. So I've got to go through the nums array. So the way to do that in Python is for nums and nums. And for every number, I'm going to look at all the elements that came before it. So I'm going to have another loop. So for I in 0 to the current index. And I get the current index by enumerating nums. Nums by double equals num, return true, and at the end, if I do not see any repetition, then I'm going to return a false. Yeah, so this is going to pass the test cases. This is going to pass the sample test cases. However, it's going to fail the actual test cases. So one thing I'm interested in looking into is enumerate here. So enumerate seems to return an iterable with tuples, an iterable of tuples that contain where the first element is the index and the second element is the number. And yeah, in the future I would like to understand what exactly iterables are and how exactly the deconstruction here is happening. Sure, let's submit this and see that it times out. And notice that it times out. Yeah, time limit exceeded. Great. So the solution to this would be to check if a particular number exists in constant time. And so for that, we can use a hash table, right? So given a particular number, I can tell whether or not it exists. Given a particular number, I can tell whether or not it exists by looking up its value in the hash table. If it exists in the hash table, then it means that there is a duplicate, but for a given value, if it doesn't exist in a hash table, then it is not. It is not repeated up to that point. So we can use a dictionary. So we can use a hash table, and we can go through all the numbers in nums. And if num is already in D from a previous iteration, I think that's how one checks if a key exists in a dictionary. We return true. Otherwise, we can set this to be true. So we create a dictionary. And we check if the number exists in the dictionary. And then we set it to true, and we return false. Yeah, I think this should work. And this should work in linear time. Cool. An optimization here could be to make use of sets instead of a dictionary. So a set, I think, is just like a dictionary, except that you're not allocating an entire object as a value of keys. So here I assume that even true is, I'm not sure how much space it takes up, but I think using a set is likely more more efficient. But sure, yeah, so here I got experience with arrays and hashing, so arrays and dictionaries. But yeah, let's move on. Okay, so here we're given two strings, and we're asked to check if these strings are anagrams. And I think an anagram is a string is said to be an anagram of another string if it can be created using by rearranging the letters of the other string. So an anagram is a string that can be created by rearranging the letters of another string. So here, anagram and nagaram are indeed anagrams. Rat and car are not anagrams. So the way I would do it is I would just go through each of the strings and I would create a table of, I would create an alphabetical table of each alphabet that occurs in the string and the frequency. So, and then I'm going to check for two things. I'm going to check whether the size of the tables are equal and the frequency of every character in S matches the frequency of every of the characters in T. And if there is, of course, a character in S that's not in T, or vice versa, then I'm going to return false. So so I'm going to need a table, and this is a second created dictionary. And we can create a table with this is a table with constant time access, with O of 1 access to keys, to values corresponding to keys. Okay, so I think I'm going to create two tables. So I'll say T1, T2. So I'm going to have to go through every character in S, and I'm going to have to increment the frequency of that character in table T1, which corresponds to the frequency table of S. So for C and S, so for every character in S, and we'll actually just come back to this because this is a lot more, there is like subtlety here that we need to account for related to Unicode. So I'll cover it after implementing a simple solution. But here, for the moment, I'm just going to assume that C is going to be a character in the way that humans think about characters. So T1 of C equals, so either I've got to set it so I've got to increment the value, but it's possible that it does not exist, in which case T1 of C would cause a key error in Python because the key does not exist. So I think this is the idiomatic way to do it. Dot get, and do the same for T. So if, and now we need to compare the lengths of table 1 and table 2. And now we need to go through every key in table 1 and ensure that we need to ensure that the corresponding value in T2 is identical. So how do I go through every key in T1? So can I say for k in T1, for C in T1, is that a valid way to iterate through the keys of a dictionary? I didn't think so. So actually let's experiment with that. Let's experiment using an interactive terminal. So let's create a dictionary. Oops. Okay. For key in D, print key. Okay, that's awesome. So it prints. So for X in D gives me the keys, which is interesting, which is really good, which is convenient. So, so the for in notation, when used with dictionaries, gives me keys of the dictionary. So if now I've got to compare the frequency T1 of C is not equal to, it's possible that the T2 does not contain C, T2.get C 0, return false, but if all the frequencies are the same, I can return true. Awesome. So this works. So the runtime complexity is O of n, because I'm iterating through both the or rather O of length of S plus O of length of T, which is, and both the lengths are in the same range, so therefore it's O of N. But what if okay, let's move on to the Unicode part. And this is, I think, quite a tricky part. Because, for example, if you have a fancy character, a fancy Unicode character, it's possible that a single character can be broken up into multiple runes. I think it's called runes in Go. But yeah, I feel like it's just stupid, just an implementation detail that I don't want to concern myself with. So I think I'm going to be able to figure it out if I really have to. So I'm just going to move on. I don't like Unicode. I just don't want to do it. Let's just move on. Yeah, it's just so stupid. We're kind of enjoying complexity for the sake of complexity. It seems like to me. Again, I'm sure it's not true, but from the outside, as a layperson, as to compiler or to string design, compiler string design, I just think that it's just unnecessary. I think things should be made as human-like as possible, and we shouldn't be forced to think of things in ways that computers think, especially when it comes to strings, for out of all things. Stupid. Anyway, so here we used dictionaries, and the strings were in effect arrays of characters, which is interesting. So let's move on to Tucson. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Okay. I think I'm actually going to take a break here. I'm just not motivated to do this problem. I don't know. It just seems so boring and so... Yeah, it just seems so pointless, to be honest. So, about 20 minutes, interesting. Yeah, so, but I think the first two problems did teach me a thing or two about Python. The for-in notation as applied to dictionaries. That's one thing I learned, and I just practiced I think the idiomatic way to look at to get the value of a key that possibly might not exist in Python, which is by using the get method on dictionaries. And yeah, so Python seems to be a very interesting language. I know that everything is an object internally. And yeah, it's something interesting actually, Python. It's something that I might look into in the future. Yeah, let's just take a break. I'm not sure how long I'm going to need in order to get my mood back up, get my motivation back up to do these problems. Yeah, let me just remind myself why I'm even doing Leetcode. Okay, so I'm doing Leetcode because The Primogen says it's a secret handshake that it's like a standardized test that you just get good at, just good at, because it's just practical to get good at it so that you're able to very easily convince others of your proficiency in programming or proficiency in your ability to learn things that are in the same area as programming. But yeah, so I think this is one of the things. However, of course, you need projects, you need, you need a lot of other things as well. But this is a secret handshake. But you just do it. Just do it. Yeah. Sure. Yeah, it just feels pointless though. Would just rather work on the shell project, the shell Codecrafters project. Yeah, I'm gonna have to continue this at a later time. I'm simply not in the mood for any more Leetcode. I'm gonna end the stream and continue some other time.